Well, hey there, fellow YouTube traveler, and welcome to the GameDev Tavern. Come on in, grab a seat, make yourself at home, and join me as we create some fun little arcade games together. My name is Nicholas. I've been a software engineer for more than 20 years, and more recently, I have been leading engineering teams working on Gmail and chat at Google for the past 8 years. So today, I'm thrilled to kickstart a brand new tutorial series where we're going to be creating a full arcade soccer game from scratch in Godot. We're going to be exploring a ton of interesting topics, from shaders to advanced state machines, from creating natural-looking AI behavior to local multiplayer, and so forth. This tutorial series is going to be somewhat more advanced than the beat-em-up series, so if you're just getting started in Godot and you haven't gone through that tutorial series yet, I'd strongly encourage you to go start with that one and then just come back here right after, so it'll be easier to understand. All right, let's take a few minutes and look at what we're going to be building together. And welcome to Super Soccer. So this is a tiny arcade soccer game which can be played either in solo or with 2 players in local multiplayer. Let's hop over into the solo mode, and the first thing we'll need to do here is to pick a team amongst 8 different squads. Each of those teams actually has a different set of players with different stats and abilities, which should create a little bit of a different challenge every time. So it's actually a lot easier to win the game with the Brazil team than it is with the USA team, for example. So I'm going to go with the easy route here, and after picking a team, the player will end up in this tournament bracket. We start off in the quarterfinals, and the objective here for the player is to win 3 different matches in a row in order to win the World Cup. So I'm going to go ahead and press a key here to enter the game. I'm currently the Brazil team located on the left-hand side. I currently have the ball, and there's basically 2 buttons to play the game, a pass key and a shooting key. And when I have the ball, I can use the pass key to pass the key to one of my teammates, and I can request a pass using the pass key again. Then when I use the shooting key, I can just shoot the ball, and the longer I press the shooting key, the harder the shot. Now I can also use my shooting key to create, to do a tackle. Here, let me show you here. And if I don't have the ball, I can also press the pass key to request to take control of whichever player is closer to the ball. And this allows me to just get into the action a little bit faster. All right, perfect. So here the Italian team has just scored a goal. As you can see, there's a little bit of animations, and people will go back to their starting positions before we can actually start playing the game again. A couple of additional things. You can see here that all of the players move their own independent agents. We're using a technology here called steering behaviors, which is a technology used to generate natural looking movement and behavior for our AIs. And there's some basic particle effects, nothing really crazy. The one thing that I do want to point out in this game here is that you can see here there's no out of bounds. Even the goalkeeper cannot actually keep the ball. And this is meant to just keep the ball in play as much as possible so that it just feels more arcadey than anything. Finally, there's a couple of interesting mechanics here that we can do. Power moves. So for example, here, if I request a pass, let's see, I need to time it right. So if I request a pass, I can actually either volley kick the ball. Oh, did I just score against myself? All right, there we go. Okay, so here I timed a bicycle kick, and let's see if I can show you a different power move. There's a header and there's also a volley kick. So this is a volley kick, and maybe we can score this. No. All right, let me see if I can show you a header. All right, perfect. Okay, well, we scored. So the game is now tied 1-1. The game will actually go into overtime. We won't allow any games to be tied, so it always results in a game a team that wins. Let's see if I can show you the overtime here after 14 seconds. See if I can show you a header as well. So I need to pass the ball and be a little bit further. There we go. All right, so we are now entering overtime. As you can see here at the bottom, we have a very simple UI that shows the score line, the time left, and then whoever currently has the ball. So currently, let me see if I can score a goal here. All right. There we go. Perfect. All right, so here Brazil has won 2-1, and after this I'm hopping back into the tournament screen. You can see the scoreline of every other matches that has been simulated, and we're now moving to the semifinal. Basically, the gameplay will continue on until the player has completely won the game. Let me now show you real quick the 2-player mode. So if I launch the game again, and here I pick 2 players, there's basically going to be two options. Either both players end up picking the same team. So here, if I was to pick France, we'd actually go back into the tournament screen and we do exactly the same thing as in solo mode, except now both players would be part of the same team and would play co-op in order to win the tournament. If, on the other hand, I have both players pick a different team, then once the selection is confirmed, they would actually hop directly into the match game, and it would just be a simple versus game 1v1. That's it. So this is, pretty much the game that we'll be building together. It's a pretty long and exciting journey. So before getting started in coding, I'd actually strongly encourage you to take a few minutes and go play the game yourself, so you can get a good sense of the gameplay mechanics and what we're going to be building. So I'm going to be including a link in the video description, and it's going to be a link to the published version on itch.io. Just hop over there, play for a few minutes, and then when you're done, come back here, and then we can get started. All right, well, hopefully you had some time to pause the video and go play the game for a little bit. We'll go ahead and get started. So when running a Godot, we are currently using the version 4.4.1, which is the latest and most stable version of Godot. At the time you are watching the video, you are probably going to see a more recent version. I would just encourage you to use the latest and greatest version. At least until we reach version 5, this tutorial should work across the board. So let's go ahead and click on Create. And I'm going to call my project Soccer Course because I'm going to be using this for all of my YouTube videos. Feel free to call yours something different. And I'm going to put my project inside my Godot 4 folder. Again, just pick a folder that works for you. In terms of renderer, we are going to be picking the compatibility renderer. At this time, that's the only renderer that allows us to publish the game on web, and the objective here is to publish it on itch.io. So the WebGL renderer here can be used, and you can just leave the rest by default. All right, and here we are in Godot. Hopefully this interface is familiar to you. Let me actually start with a quick trivia question. What do you think is the most important thing that you could be doing whenever starting a brand new game dev project? And there's no perfect answer here. Some of you might think about focusing on core game loop using placeholder arts. And some of you artists might actually think, let's start with the graphics instead, because, let's face it, placeholder art really sucks. And others might want to focus on a single building block, like a core mechanic such as player movement. And some of you might even think don't even write a single line of code, don't draw anything, just work on a design doc, just make sure everything is clear in your head before you start the project. And all of those answers are actually great. But to me personally, one of the most important things that I do when I start a brand new game dev project is setting up version control. So if you haven't used version control before, just think of it as a way to save your game dev progress over time, using checkpoints that you can go back to in case you run into any issues. Just think of those as checkpoints in a video game. So on my end, I'll be using version control throughout this series, and as we make progress implementing various pieces of the soccer game, we'll be creating those checkpoints along the way. So in case anything goes wrong, such as my computer crashing or dying, or maybe our game stops working for some obscure reason, we'll be able to just revert back to a working checkpoint. Now, I don't want to force you to do the same on your end, but to be honest, using version control is just such a fantastic reflex and tool to have for all of your projects. It will just save you so much time. There's a lot of version control tools out there, but our game is very lightweight on assets, so we're actually going to be using the most common and famous tool out there called Git. And fun fact, Git was actually built in about 5 days by the same guy who built Linux. So yeah, there's a pretty smart dude for you. Now, for those of you who don't have Git installed on your machines, I'm just going to take 2 quick minutes and show you how to install it and set it up so that you can follow along with what I'm doing as well. So Git can either be used through a visual interface or via the command line. And if you're not sure what to get, just hop over to git-scm.com, and then in there, hop over to the download section, and then go to the graphical user interface client. And then you can just pick the GitHub desktop here, which is just a great choice for beginners. So personally, I'm going to be using the command line interface, but the result is going to be exactly the same. And once you have Git installed, you can now start creating those checkpoints on your local hard drive, which is already pretty cool. But to go even one step further, you can actually store these checkpoints online. And the most popular and free solution to do that is github.com. So if you don't have a GitHub account, just hop over right to github.com, enter your email here, and then you can sign up for a free new account. Once you have created your account, you'll need to connect your computer to your GitHub account so that you can easily transfer the checkpoint information. And I'm going to be putting a link in the video description for you to follow, but basically it comes down to just following 2 steps that each take 30 seconds. And these steps are generating a new SSH key. This is a way for the computer to only communicate with GitHub for its account, and then adding this new SSH key to your GitHub account. And once you have completed these steps, you can just hop right back over to github.com. Your main page will probably look a little bit different than this because you have a different set of projects. Just go ahead and click on New to create a new repository. I'm going to call mine Soccer Course, and I'll give it a quick description. Course for building a 2D soccer game in Godot. And I'm going to make my repository public, meaning that anyone in the internet have access to the code and the assets. This is done on purpose. I actually want people to be able to use this for my YouTube videos so they can jump to any episode checkpoint as needed if they want to start from the middle of the course if they wanted to. However, I usually set mine to private unless absolutely necessary, and just to keep those things while they are currently in development. So I'll let you pick whatever you want here. Adding a README file is always a good practice. And then a git ignore, we're going to pick the Godot template. So what this does is basically tells Git to ignore some files that Godot might be creating. Godot currently uses a lot of caching mechanisms and temporary files and folders, which we don't really care for. It's okay if they get deleted. And then in terms of licensing, again, I'll let you pick whatever you want. I'm actually all for open source. I want you guys to be able to do whatever you want with the code and the assets, the arts, the audio files, and so forth within this course. So I'm going to be picking MIT license, which is a pretty permissive license. Feel free to polish the game that we're making. Feel free to go sell it on Steam, become a billionaire, just go crazy. But yeah, so this is kind of my preference, and just use whatever you feel is best for you. Once you click on Create Repository, it's going to create this special folder online, which is currently kind of empty. It only contains a few files. But as we make changes and as we store them, you're going to see all of those changes being reflected here on GitHub. So what we'll want to do is we'll want to start by cloning this folder to our local hard drive and make some changes to that folder. That folder currently only sits on 9, and we want that to be cloned to your local hard drive. So for that, we're going to be clicking the code button here, and inside this SSH tab, this is the location, that's kind of the address of the project that you've just set up. So go ahead and click on copy URL to clipboard. And then once you're done with that, you'll want to kick off your Git tool of choice. So on my end, I'm only using Git Bash, and I'm going to navigate to the parent folder where I have all of my Godot projects. So in order to clone or copy the contents of this online folder to my local hard drive, I'm going to use the command git clone, and I'm going to paste the URL that I've just copied over. By pressing enter, it's going to create a new folder called soccer-course inside my Godot 4 folder. And this will contain the contents of these repositories. So if I navigate there, you'll see the exact contents, git ignore, license, and readme.empty. So now we're kind of in an awkward spot where we have created 2 folders for the same project. One of them here was created by Godot. This is an empty Godot project. It's currently located inside my Godot 4/soccer course. Notice that there is no dash here in the middle. And then here, this soccer dash course, this is my Git project, which is currently an empty Git project. Doesn't have anything related to Godot whatsoever. So what we want to do, we're going to be using this as an opportunity to illustrate how version control works. And we'll be repeating that process, by the way, many times throughout this course. So, don't worry if this still feels a little bit foreign. So the first thing you'll need to do is just quit the Godot interface. And then we're going to drag over the contents of the Godot project over to our Git folder. So just drag it from one end to the other. Godot, the empty Godot project actually contained a git ignore file. Remember, this is a file that we added when we created the Git project. Basically, Godot just assumes you're going to be using Git. It's just such a common thing to do. So we can actually just keep this file for now. And we can only keep this. So you can get rid of that folder, which is empty. And we're going to only be using this Git folder moving forward. So once I'm in this Git folder, I can type a command called git status, and this will tell me what is the difference between what Git knows about and what is currently on my hard drive. And Git detects a bunch of new files that it's never seen before. Doesn't know what to do with them currently. Should I persist them? Should I track the changes or not? So they're currently marked as untracked. And we want to tell Git that we're actually interested in tracking the changes for all of those new files. So we do this using a command called git add and then dash capital A to add all of those files. So now Git will start tracking all of those changes. If we type git status again, it tells us, hey, I have a bunch of new files that are new, I'm tracking them. However, they're currently not on your online folder. They're currently brand new and they're not stored anywhere. So in order to persist those changes online, Git uses special objects called commits. And a commit is just a very simple list of changes between various files. For example, if you were to add a new line to a text file or you add a pixel to an image, it's just a simple structure. It just contains all the deltas, the difference between two versions of the projects. So in our case, the delta here between our project and the one on GitHub is all of those new files that are currently listed in green. So we're going to be creating this commit object by typing git commit, and then you can give a descriptive message to tell Git what that package contains, what it represents. So here I'm just going to type this added empty Godot project. Okay, and you can see here that it created an object where it added all of those files. And now if we type git status, it tells us that everything is ready to go, but we're a little bit ahead of this folder here called origin main, which is this online folder, by one commit. And we can publish our local commits, or what's on our hard drive, we can publish that online by using a command called git push, which is exactly what we're going to be doing. So git push currently just takes a few arguments. We're going to keep things simple. We're just going to tell Git to copy what we have on our hard drive and send it over to this main branch here. All right, so now that we have sent this online, if you refresh your GitHub folder, you should now see the new files. And if you click on this commits button here, you can see that we created a commit object. This is the ID of the commit. If you click on it, you can actually see the contents of that commit, which is all of the delta, the difference. Basically right now is all of those new files. And if we were to make a change inside one of those lines, then we could create another commit just for that change. Anyways, there's just so many things we could talk about here, and we're going to be revisiting this concept over and over again, and we're going to make that hopefully a habit in your game dev journey. We'll be using it constantly, so you'll get into the habit of this, of using GitHub, and again, it's just such a lifesaver. I really strongly encourage you to do that. Okay, so now that we have Git set up, we're now ready to get started, and let's go ahead and start Godot again. All right, so Godot is going to be complaining that your project is now missing, which is perfectly fine. We deleted its content. We're going to remove this one, and we're going to import the project where the Git project. So go ahead and click on import and locate the folder where you have your Git project, which now contains an empty Godot project as well. Click on select current folder, and then go ahead and click on import. Okay, and we are back inside Godot. So there's a couple of things we're going to be doing today. I know that we're getting short on time. I want to keep those each episode to roughly 30 minutes, but hopefully we can at least get some amount of visual elements here on the screen. So there's a couple of things we're going to be doing today. First, we're going to be importing all of the assets that we need for the game. Second, we'll do a few tweaks to the Godot interface here so that it makes it easier to work with 2D games. And third, we'll work on our background and then potentially our main character scene as well. So let's go ahead and import all of the assets for the game. There is a link in the description to download a file called soccer assets. Just go ahead and unzip that on your local hard drive and then just drag that assets folder into your Godot project. So this will bring in all of the art, fonts, music, and sound effects needed to make the game. Feel free to take a minute and explore the contents. Actually, every time we add a lot of files, it's always a good checkpoint for us to push that over to Git. So I'm just going to do that as well really quickly. So here I'm going to add all of my new files. Again, you could say git status. You can see that we have this new folder called assets. We want to add all of those things. So git add space dash capital A. It's now adding all of those files, and I'm going to commit added all assets for the game. And I'm going to push this to GitHub. Perfect. Next up, we'll need to do a few tweaks to declutter the editor. So at this point right now, this is Godot provides by default a bunch of 3D elements. And if you create a new node, you'll see that there's going to be a bunch of 3D related stuff. This is great if you're working on a 3D or a mix of 3D and 2D things, but because we're building a purely 2D game, we actually won't be needing half of that. So there's a way to declutter the UI of Godot, which is very convenient whenever you build a 2D game. And we're going to be doing this right away. So to do this, we're going to create a new editor profile. You want to click on Editor, click on Manage Editor Features. And then here, I'm going to create a new profile, and I'm going to call this 2D. And as part of this profile, you want to uncheck anything that's 3D related. So I'm going to uncheck 3D editor. I'm going to uncheck asset library we're not going to be using. I don't think we're going to be using the history doc either. And then if you hop over to the node, let's see if I toggle this. Yeah, you want to uncheck the node 3. We could actually uncheck a bunch of additional things, within the resource folder. But right now, I think this should do. So now whenever you create a new node, you would only have the node 2D aspects. All of the 3D stuff has disappeared. Just makes it for a lot less cluttered environment. It's a lot easier to work with. So next, we'll need to tweak a few project settings that are going to be useful for this game. We'll be setting the resolution and then making sure that the textures are imported properly. So hop over to project settings. And bring this back to the middle here, and then hop over to display window. The resolution of our game is going to be 280 pixels by 180 pixels. It's going to be a pixel art game, which means that if you're to run this window would be much too small. So we are going to upscale this. Make sure you have advanced settings toggled on, and then if you scroll down to the width height override, you want to multiply those numbers by 5, meaning that the width will be 1400 pixels and the height will be 900 pixels. So that's going to be the size of the window. The resolution of the game is going to stay the same. Next up, we'll want to scroll down over to the stretch mode to indicate to Godot how it should be stretching and upscaling the game. We want our mode to be set to viewport, so that way it always aims at keeping the ratio 28 over 18. And then we want to have the scale mode set to integer. That way we always work with nice square pixels. Lastly, we'll hop over on the left-hand side and scroll down to rendering and then textures. And if you scroll back up, you want to set the texture filter by default to nearest. This will avoid any sort of compression, blurriness to our pixel art textures. All right, and with a few minutes left, we'll start working on the soccer gameplay. So for that, we'll need to have a root 2D parent scene, which will contain all of our 2D objects. Let's go ahead and click on 2D scene here, and let's press F2 to rename it, and I'm going to call this world. Press Ctrl S to save the scene, and we're going to be creating a folder called scenes. And within this scenes folder, I'm just going to save my world scene here. All right, and now we can press F5. Godot is going to ask us to pick a scene by default. We can just select current, and here we can see our game starting. Amazing. All right, let's go ahead and add something. So I actually always like to start by adding some background. It's usually pretty fast. It helps make sure that the textures are imported properly, they're not blurry. It's a helpful canvas, especially when you start working on things that need to move across the screen, like our playable character. So our background is actually comprised of 3 different layers of background, 3 different sprites. So let's go ahead and start by creating an empty container to hold all of those sprites. So back onto the world view, I'm going to hit Ctrl A. You could press this plus sign as well. And then here we're going to create a node 2D and F2 to rename it. And I'm going to call this backgrounds. And then we're going to add 3 sprites to this. Let's start with the first one. Ctrl A, sprite 2D. And this is just going to be the grass background, the color background. So I guess we could call it grass for now. And then inside your folder here, you want to look for a file called pitch background. You want to take that image and drag it over to the texture property. So first of all, you can see that the texture is much bigger than our play area. This is normal because we're going to be scrolling through the pitch as we play. But the main thing that we'll be doing every time we work with textures is we want to remove the centered offset. This is because we don't always work with textures that are that use even dimensions, and so we just want to make sure that everything is nice and even here. Next, you're probably wondering, like, why the heck is the grass white? We're not tricking the players on playing in the snow here. This is something that I've done on purpose and that I usually do in a lot of games. You can see that every node 2D or every node that inherits from node 2D has a visibility property, and as part of this container here, you have a modulate property, which allows you to add a solid color to the existing base color. So here, if I was to pick yellow, for example, this would kind of make it feel like the players are playing on the sand. So by just tweaking a color, you can actually create different sort of pitch surfaces, and that just opens up a lot of possibilities for what you want to do with the gameplay. On our end, we're going to start by using a green, I think I used 84 CD2A as my base green. And then let's go ahead and add an additional sprite on top of this. So back on backgrounds, go ahead and click Control A, Sprite 2D. And this one I'm going to call pattern. And I'm going to drag the pitch pattern image onto the texture property. Once again, you want to remove the offset. And what this does, first of all, let's just go ahead and add a different green color here. I'm going to make it a slightly more darker green, 498B00. And when you scroll up, you can actually see that this is meant to be reflecting the work of the lawnmowers. And you could have different type of patterns. Let's say you're working, you want to have a pitch that reflects the dirt field or a sand field. You can then work with different patterns to make it more immersive. And finally, this kind of looks like a park. So let's go ahead and add our third final sprite back into the backgrounds container. Control A, Sprite 2D, rename this to lines, and then just drag the pitch lines texture onto the texture property. Once again, you don't want that to be centered, and there we go. It's starting to look a lot better. I'm actually also going to tweak the modulate property here. I just want to use some form of off-white rather than have this pure white here. So I'm going to use F0, 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 and then press F5 to start the game. All right, and this is already looking much better. It's actually a great time to create a quick checkpoint in Git. So once again, we'll do that over and over again. Let me bring up my Git tool interface here, and I'm going to add all of my changes. I'm going to create another commit, and here the message will be simply added pitch background, and I'm going to push those changes over to GitHub. All right, so look, I know we're already out of time, a couple of minutes over the half-hour mark, but a lot of it was mostly setting things up, and I actually really want, I really want to have our character visible on the screen before calling it a day. So, please bear with me here for a few more minutes so we can get that character on screen. So every time you need to create an important object in your game, such as the soccer player that we're going to be doing right now, it's really, really important to take a minute to think about what would be the best node type that we can use to represent this object. So whenever we create this here, it's going to ask us, which node do you want to use to represent the object. And let me just take a minute and walk you through how I tend to reason about those things, how I make that choice. All right, so I've listed here 8 potential viable candidates that we could be using to represent our soccer players. They go from node 2D, sprite 2D, area 2D, and then all of the physics objects that we have from rigid body, static body, animatable body, and character body. So let's go over those one by one. Because we'll be working in a 2D space, we can actually get started by getting rid of node all 2D. We don't want to have to write ourselves the X and Y position, just we want to use objects that have that built in. Second, we'll need to support collision detection. And because we don't want players to get out of the soccer pitch. So this means that we can already get rid of node 2D and sprite 2D. Next up, we actually want to be able to collide with physical objects, not just with other areas. And so we can actually get rid of area 2D as well. So we're left with the 4 physics body objects that Godot offers. Those are good options, and we can go over those to try to find which one would be the best one. So first of all, we actually want fine-grained control over the movement. We don't necessarily need that to be physics-based, so we can actually get rid of rigid body 2D altogether. And also, we want our physical object to be able to collide while moving. This is something that's really important that isn't offered by static body 2Ds, which tend to go through other physics body objects. So we can get rid of that. So it pretty much leaves us with 2 viable candidates, and those 2 candidates could actually perfectly work. One of them is animatable body 2D, while the other one is character body 2D. The main difference here is that character body has a lot of built-in functions and APIs for moving and sliding against slopes and other objects. And because we're going to be wanting to slide against the walls of our pitch, character body 2D is actually probably the better choice than animatable body 2D. But you know, we're going to be going through that same process for figuring out what is the best node for our ball, for example, for the soccer ball. And here the choice would actually be different because we don't want the ball to slide against the wall. We actually want that ball to bounce against it. So we don't need all of the APIs that is provided by character body 2D. So when it comes down to creating a scene for our soccer ball, we'll actually be picking the animatable body 2D instead. But this is just a quick example, right? I think for every single node that you write, just go over that list of potential viable candidates and just go through that checklist and think through what would be the best candidate, what would be best for you to use. If you have to end up writing a bunch of things that are already built in a different node type, I would just go over and use that node type instead. So let's go ahead and use a character body 2D to represent our soccer player. So back into Godot, I've clicked on the plus sign to create a new scene. We're going to click on other node and pick the character body 2D node. And I'm going to press F2 to rename this, and I'm going to call this player. Okay, and next up, let's go ahead and save it to our, let's go to scenes, create a new folder, and I'm going to call this characters, and save it under our scene/characters folder. Okay, we're going to be adding a couple of child nodes to this node. So you can see there's a warning sign. This is because we're creating a physics body that doesn't have a collision shape. We're going to be adding that in just a second. First, let's just add a sprite to see what that player looks like. So on the parent scene, Control A to create a new child scene, a child node, and we're going to pick sprite 2D. And I'm going to rename this to player sprite. And inside my folder, I'm going to be looking for an image called soccer player, and you drag that PNG image to the texture property. So this is a sprite sheet. It contains multiple animations. If you zoom out a little bit, you'll see that there is 13 different animations. Each animation is positioned on a different row. This is something that kind of my preference, but you could, tweak things however you wanted. And then each animation has a maximum of 6 frames. So we're going to set this up inside the properties of that sprite 2D node. First of all, once again, you want to get rid of that offset. We'll be setting that ourselves. And then inside the animation folder here, we're going to set up the fact that we currently have 6 horizontal frames. So 6 columns here. And we have 13 different animations. So VFrames set that to 13. All right, and next, because we're building a 2.5D game where objects can overlap on the field, so we have multiple players that will be next to each other, we actually want to make sure that things are properly Y-sorted. And Godot makes that very easy. There's a property called inside the ordering here called Y-sort enabled, which makes sure that it compares all of the nodes and its nodes' children to figure out which ones should be drawn in front of the others. And to make things really easy here, we're going to be using a convention throughout the entire game that every single object that needs to be Y-sorted will have the root, so here we're thinking about the shoes or the root of the character, positioned back at the Y equals 0 axis here. So we're going to be using the offset property to set that up ourselves. We're going to be setting the offset of X to -16 and -32 for Y. And so now you can see that the Y, you can see the feet align here with the origin. Let's go ahead and add a few more things. So we're going to need an animation player. So back into the player routine, I'm going to hit Control A, find the animation player. Make sure you don't pick the animation tree. And let's go ahead and create a first animation. So animation, new, and let's call this idle. It's going to be the default animation, and we're going to make it loop. And it's going to have a length of 0.6 seconds. And we're going to set a snap to 0.15 seconds as well. Zoom in a little bit, and then clicking on the player sprite, we're going to be picking frames 0 through 3. So when you click here, it's going to ask us if we want to create a reset track, which we are going to be doing. This is just a handy way for Godot to be able to get back to an original state, and just click create here. And then we're going to click on frame 0 3 more times so that it actually shows the entire animation. All right, and we can click on the play button to make sure that things are working properly. Let's go ahead and save. Next up, so again, Godot is complaining here. Let's get rid of that complaint. We can go ahead and create a collision shape. Control A, collision shape 2D, and here we're going to create a capsule. And let's go ahead and rotate it first. We're going to rotate it by 90 degrees. And we are going to, so click on the capsule here. We can set multiple things. Let's set the radius to 4 pixels and the height to 18 pixels. And then let's set the position up by 3 pixels. Now let's go ahead and bring our player into the main world scene. So Control S to save. Let's go back to the world scene. And here we're going to click on the world. Control Shift A this time to select a scene that we're going to instantiate. And we're going to pick our player scene. And the player scene is currently over there. Let's hit the Alt key, and then you can drag that player around. We'll just bring him to the middle of the pitch right now, or middle of the screen. If you press F5, we should now have a working idle player that is in line with the game. All right, so this is a perfect point once again to create a quick checkpoint inside Git. So let's go ahead and do that. I'm going to open up my command line interface. And I'm going to create a new commit, add static player with idle animation. And I'm going to push that over to GitHub. All right, and this is going to be it for the first episode. We have so much to cover still, so I really hope that you stick around for the next ones. In the next episode, we'll start putting together our more concepts around our player character and start working on a complex state machine. So we have worked on state machines before in other tutorials, but this one is going to be a little bit more advanced. We're going to be talking about how to do this in the proper way. If you have any questions regarding anything that we did today, please hop over in the comments section. I'll do my best to respond quickly. And if you like this type of tutorial and you want to see more of those, please consider hitting those infamous like and subscribe buttons so that the YouTube gods can reward me with fame and karma. Time to take a quick break, and I'll see you in the next episode. Cheers!